So our next speaker is very special. Why? Because we had a lot of experts in the area of medicine, biology, biological science, genetics, so on and so forth. But the next speaker actually is an expert in a very different area. She's an engineer. So I would like to introduce our next speaker, Dr. Jingying. So she's a professor at the National Engineering Research Center for e-learning at Hangzhou Normal University. She got her Bachelor's of Engineering, Wireless and Communication Technology. So a lot of technology expertise and informational engineering at Hangzhou University, sorry. And her MS from Institute of Pattern Recognition and Artificial Intelligence. So she also stayed in the UK for a while, also in the area of informatics at the University of Edinburgh in the UK. And her research interests include technology enhancing learning, computer vision, and pattern recognition, human-computer interaction, intervention for children with autism. She has published many papers, more than 40 papers in international journals and also international conferences. She also published 2 books as well. So based on her research achievements, she is going to let us know, share with us more about her expertise. Let's welcome Dr. Chen.
Good afternoon, everyone. Thank you for inviting me here to give your talk. Today, I'm going to give you a brief introduction of our work, computer-assisted learning for children with autism. My talk includes 5 parts: motivation, objectives, methodology, and some computer results, and conclusions. So, research emphasizes the importance of social and communication skills as the basis of learning by all children. Children with autism have difficulties in communication, so learning is more difficult for them. Research indicates that many children with autism have difficulties in face-to-face communication, but they have a natural affinity with technology devices such as computer. Computer offers a safe, predictable, and controllable learning environment. And research indicates that computer-assisted learning can be effective for children with autism. For example, some researchers using the technology of virtual reality to help children improve their skills to find a seat in a busy cafe or a busy bus. And other researchers using the technology of multimedia to show the social story and help the children understand some social rules and some social situations. There is a computer-assisted instruction program in Los Angeles. And in this program, 47 preschool children are involved. They are divided into 2 groups. One group used this program 20 minutes per day over 3 months. And this group used this program showed more improvement overall on language and cognitive outcome measures. There are many special schools use different kind of technologies. And also, connector can be used to help children improve their motor skills and collaboration skills. Stephen said that if you met one person with autism, that means there are big individual differences in autism. Children with autism experience different developmental trajectories. So the personalized learning scheme according to the individual needs is very important. So computer technology can create an intelligent learning environment which can adapt to the individual needs. For example, we can use a face recognition technology to load the personalized learning scheme automatically. And we can use the facial expression recognition to estimate the child's emotion states. Also, for the gaze tracking and the head pose tracking, we can estimate the child's attention during the learning. A computer game is not new for education and proved to be effective for children's learning. Research indicates that games based on virtual reality simulations increase the possibility that the skills learned in this kind of environment can be generalized to real-world settings. So this environment is ideal for the children with autism who typically experience discomfort at some expected change and uncertainty of face-to-face communications. So the game-based technology enhanced learning is necessary to be investigated. The objectives of our research is to provide appropriate support to early interventions for children with autism, which includes to create a safe, motivating, and technology enhanced multimodal environment, allowing children to interact with virtual character, explore different social situations, and improve their abilities. Multimodal environment is similar to the real world. Children can sense the same social signals, voice, vision, and physical interaction such as touch. So this environment also can accommodate different developmental pathways. So that's our objective. So this kind of research is interdisciplinary research. So this environment is designed and implemented incrementally in a number of cycles: design, evaluate, implement, and then evaluate. And so the research includes 3 stages. First, design the learning objectives and learning activities, then create the intelligent learning environment, and finally evaluate the learning environment. We design the learning objectives and learning activities based on a series of psychological functioning in the field of child development. So there are many series in this field, each of which has something to offer in terms of understanding the cognitive and social development of children in general and difficulties associated with autism in particular. Individually, they are likely to give a full explanation of autism deficit and are therefore unlikely to provide a sufficient base for learning. So we choose 4 key cognitive theories of children development as a framework for this research. First is theory of mind, executive functioning, and central coherence, and intersubjectivities. So our learning objectives and learning activities are based on this series. Next, we create an intelligent learning environment so the child can interact with the virtual character, virtual scenario through the multi-touch server, and the cameras monitor the child's behavior. So there are 5 modules. There's 5 modules in this system. The first one is the visual input process, which includes face expression recognition, and then the gaze tracking and head pose tracking. For the expression recognition, we can estimate the child's emotional state, and the gaze tracking and head pose tracking, we can estimate the attention of the child. Then a child can physically interact with the system through the multi-touch server. Gesture sensor ensures that the system knows what the child is touching on the screen. So this is the second module, multi-touch server. The next one is a multimodal fusion module. This module fuses sensory information recognized through head pose tracking, gaze tracking, and expression recognition. together with the child's gesture. So this fused information forms the child's affective and cognitive states, that's the attention and the emotion states. So then the intelligent engine provides the child with narrative experience in which the child is an active participant. So the intelligent can choose appropriate scenario according to the child's affective and cognitive states. Rendering engine generates the audio-visual outputs, such as the graphic scenes on the display. And there are two challenging issues in this system. The first one is the facial expression recognition. So firstly, we detect the face based on the highlight features from the images captured by the camera. And then we locate the facial feature point within the face region based on the active shape model. Finally, we recognize the different expressions based on the support recognition method. The next challenging issue is the head pose estimation. And in this system, we use the Lucas-Canada algorithm to track the detected feature point and then estimate the head pose using POSIT algorithm. And finally is the evaluation. We evaluate the system at two levels. The first one is the micro level objectives. Those are correspond to the specific development objectives, such as to increase a child's scale of joint attention. So we can use the head pose tracking and gaze tracking to estimate the attention and the duration of the decision making. And the second level is the macro level objectives. Those are referred to as developmental change in the child's skill and ability to generalize those skills to local situations. There are some, because this is ongoing research, so there are some preliminary results. So based on that series, learning activities include 6 modules: cognitive skills, vision skills, and fine motor skills, social interaction skills, classification, and memory skills. There are some demos of the learning activity. For this one, it's cognitive skills. There are some they try to improve the children's basic knowledge, such as numbers, counting, and important signs. There are vision skills. For the vision skill, includes the shape and the color and tell the difference between two images. And there are some social skill training and social interaction. For this one, is the joint attention training. So the child has to follow the two characters' social clues to complete a task. And this one is to try to improve the child's skill of reasoning about others' mind. And this one is about the expression reading. And there are some fine motor skills. For this one, try to catch the ant that the child have to pinch the ant, and this one is to point the hose, and this one to drag the basket. So will improve the skills of different kinds of practice. And this one is the classification. Annual classification, transportation tools classification, and color classification, or the ages classification. They're just some demos of the learning activities. And this one is the memory skills too. There is a demo of the joint attention training.
help me pick some flowers? I will show you which ones to pick. Great!
So the child
Great.
has to follow the virtual characters and social clues such as point
Well done.
and gaze. For this one, it's only using gaze.
Well done.
So because of the time limit, so I cannot show all of them. So there are other demos, so I cannot show them now. So we use the social stories in real world, or the social stories using animations to try to improve the children's skill using different kinds of ways. There are some other learning activities. Because this is a personalized learning scheme, so we use the face recognition to recognize the face and automatically load the personalized learning scheme. And then this part is the personal information, and this part is the personalized learning scheme. There are some demos for the headphones tracking. According to the headphones, we can estimate the child's attention. And this one is the facial recognition, so we can estimate the child's emotion state. Also, we use the database management to track the learning progress. So we have the older learning records, and we can upload the records to the server and analyze it in the future. So there are some, we have tested the system in some special schools, so I will show the videos. So we have two types of the system. This one is a big screen monitor in the university, and this one can be used at home or personally. We have some papers and patents and software license published. So this is an intelligent learning environment, and it is designed to provide appropriate support to early intervention for children with autism. We design the learning activities based on the cognitive theories and evaluations from the special school. We implement the learning activity using different kinds of technologies. And so far, this system shows encouraging results to help children to improve their abilities. Thank you for your time.
Our next speaker is Dr. Jingying. She was trained as pediatrician and psychiatrist in Harbin Medical University and Sun Yat-sen University. She obtained a doctoral degree in psychiatry in Central South University Xiangya Second Hospital. She's interested in early prevention and neuropsychological mechanism of autism. And she's currently the Vice Director of Department of Maternal and Child Health in School of Public Health, Sun Yat-sen University.
Thank you for introduction and invitation here. For autism, what we have known is that American CDC updated the prevalence of ASD increasing to 1 to 68 children. But how about in China? Maybe we have many we have many years interesting for the research of autism. The core content of my research include the core content is the early intervention of ASD. What is include prenatal stress, neuropsychology, early screening, and intervention effect. Also epidemiology. We want to know some data from China, but there still have no country data from mainland of China for the prevalence of ASD. However, we did research in Guangzhou, which is the biggest city in south of China. We use cross-section study to select 7,500 children aged 2 to 6 years from 21 kindergartens of 6 regions in Guangzhou City. By multi-stage sampling method, we use Clancy Autism Behavior Rating Scale and the information of growth and development were collected, and then the children were observed, evaluated, and diagnosed to get the prevalence of ASD. The results shows the prevalence of ASD in preschool students in Guangzhou mainstream kindergartens was 75.4 per 10,000, and sex ratio of male to female was 6 to 1. Excluded the more serious cases, for they joined in special training program. At these more serious cases, the prevalence of ASD in Guangzhou is close to that of average prevalence all over the world. I would like to show other studies. This is a Seraph Mind test in preschool children. The Seraph Mind was first proposed by Primark and Woodruff through non-verbal experiments on chimpanzees. They proposed that the primates have Seraph Mind. That is, individuals have understanding of their own and others' mental states, including recognition of beliefs, emotions, intentions, and desires, and other mental states, and thus make prediction of others' behaviors. Seraph Mind reflect the ability of social cognition, which deficit in children with autism spectrum disorders. Earlier studies applied similar assessment to autistic children and found that the understanding and psychological inherence of autistic children developed later than for typical children. Applying Seraph Mind test to children who are socially delayed is a good way to understand the development of their social ability and reach the goal of early screening and provide early intervention so as to improve the prognosis. Considering the current limitation of children's mental health care in mainland of China, screening tools are urgently needed to identify children who are likely to have communication disorders, making early detection of autistic children and Asperger's syndrome possible. As a result, we introduced the Japanese version of Seraph Mind test into China with the cultural request. To investigate the reliability and validity of Chinese version of Seraph Mind, a total of 1,095 typical preschool children complete Seraph Mind test. And we also use adaptive behavior rating scale for children. We get the data, and the results show that the retest reliability of expression recognition, expression attribution, and unexpected place test and an expected content test were all about 0.7, and inter-reader reliability was 0.95, and the subsets of zero-mind test also get the pass rate of zero-mind test increased with the development of the preschool students. So it has satisfied structure validity. And the results show that the Chinese version of zero-mind test was found to have good psychometric properties with adequate reliability and validity. In particular, the zero-mind test is appreciated for assessing for social cognition level of Chinese children. And to explore the developmental stature and the character of zero-mind on high-function autistic children, zero-mind tests were administered to 20 autistic children and 361 typical children aged 3 to 7. The passing rate of false belief test and the expression attribute will show in this slides. The false belief test score of autistic children significantly lower than that of typical children. However, there were no obviously differences on score of expression, cognition, and attribution. How about Asperger's syndrome? We also do the study on Asperger's syndrome children. This study was to investigate the performance of zero-mind test of children with Asperger's syndrome. 32 Asperger's syndrome children and 30 typical children aged between 7 to 12 years completed the Chinese version of zero-mind test. There were no significant Peabody picture vocabulary test score between two groups. This study found that the pass rate of expression recognition test in Asperger groups was lower than that typical group. But compared with the typical group, AS group had much low pass rate in expression reasoning, as unexpected places and unexpected content test. So the result is the Asperger's syndrome children were incapable in expression attribution and difficult in understanding others' false belief. And we also administered the facial expression recognition matching test for 40 Asperger's syndrome children aged 7 to 12 years. The results show that the total score of Asperger group is lower than typical group, and score of scare of Asperger group is lower than typical group, but not other expression. So we also have other. We developed a Chinese facial expression picture to use in early screening and early some study, and used in other institutes in mainland of China. And we used some strategy for infant expression cognition test, but for the time limit, we can't explain more. And that's all. Thank you for your attention. Thank you.
So I'm very excited to introduce our next speaker because he's also a child psychiatrist like myself, and he also worked in Hong Kong, which is where I came from. So Dr. Tek Poo, he's a graduate from Nanjing Medical University. He trained in child psychiatry in the Nanjing Child Mental Health Research Center. He then spent some time in Texas, at the Texas Christian University for his master training in special education. Then he also trained in Michigan, at University of Michigan as well. And then he moved to Hong Kong, and he was the director of the Rainbow Project. They are to provide behavioral and also educational services for children with autism and also developmental disorders. Then he also trained child psychiatrists, teachers, and other providers, including pediatricians, in areas of autism and also developmental disorders. He set up the Rainbow Consulting Services in Beijing, and he also works as a child psychiatrist for the Beijing Vista Medical Center and the United Family Hospitals in Beijing and Guangzhou. Let's welcome Dr. Pu.
No, I don't have any slides. I was just told yesterday I need to have a speech, but I don't really prepare. But I'm just tell a little bit my work, what I did in China, mainly. There's so much about me, but I'm a trained child psychiatrist in mainland China, and also my passion is autism because my supervisor, my director, in Professor Taogutai, who's the first one who reported autism in China. He was my supervisor when I was in residency. That's why I got into the field of autism. I think my passion with autism is led me to study special ed in Texas, and I also taught 5 years in public school with a program, a CAP program in a public school. And I'll just tell a little bit more, add on to Dr. Du this morning about the situation, condition we have in China in terms of diagnosis and also intervention of autism. We do have a few ABA, American style ABA in China, in a big city only, not in Guangzhou. It's in Beijing. We do have one BCBA certified therapist who set up center in China. And also we have one BCBA certified ABA therapist in Shanghai as well. So we're getting there. And before that, we had this pretty much Chinese style modified ABA program, which is it's not very good. And then now I get on track. And another thing is about the trainings in terms of staff, in terms of professionals, we huge lacking of speech therapists. We don't have occupational therapy in a whole nation. The university don't produce that in two areas, as we definitely need that. And another thing I want to add on is we in our program, I do have a center in Beijing to provide service directly to kids and families, but it's very small scale. And I hope I'm using this opportunity to invite everybody to come to China and to help us to bridge the gap. Language is not an issue. I think we need a specialty, we need a profession to come to China to help us. I think that'll be all for me, and I'm sorry I don't prepare anything, and mainly I'm working in the field, not in research. I help research, but mainly I'm a clinician and working on a daily basis with our families and kids in China. Thank you all.
Thank you very much. Because of your brief talk, actually you help us get caught up on time, which is so I would like to get all the speakers to come forward. Maybe we can spend, because of the short time, we probably can spend maybe 10 minutes or so for questions, and for everybody. Speakers, please come forward.
Chin and Dr. Yin. Very much impressed by your computer technology platform in China, which I did when I was at NIH here. I find that we might like to look into one step further. Instead just fishing around the symptoms, or you created an inventory, and have you validated those tests and inventory?
There are two systems in the special schools now, so we have the testing now. Actually, we have some observations. So we found that when the system works with the kids, if the kids cannot touch the screen, the system will promote the kids to touch the screen because we have the face recognition. If we cannot find the face in front of the screen, so the virtual actor will call the child's name. So with this kind of session, so we found that the kids are more engaged when they after the 3 months training, and the promotes are fade over time.
Have you looked into the connection of the genetics with those behavior testing? Because I find that you have a wonderful platform. There's no doubt about it. But if we can do one step further, look into the genetics, and you do the usual routine, robust computer testing or neuropsychological testing. And then we could try to, isolate or filter down a endophenotype, with a stable, phenotypic, measure, and then we can do a wonderful job, connecting the genetic, underlying, pinning with the behavioral symptoms. And in Hong Kong, I talked to Robert Koninger in Boston University, in psychiatry. He invented the multidimensionality, personality scale, and they, translate Chinese, they test it in Taiwan, test it in Hong Kong and China. And the first thing is to validate the test, and the second thing is to do a genetic connection with the endophenotype. That's what I propose.
Good suggestion.
Thank you. Yes.
I have a question to Kat. Yesterday, with the chat, you said when you treat a patient, you need to have a actual home visit. So what you plan to involve the parents of those autistic kids?
Yeah, we've been discussing, when we're driving car, and we were talking about, my approach in the assessment. In my practice, and only it's very rare we do home visit. I think the home dynamic is very important to assess the whole thing in terms of the future intervention. How can provide for them. So I insist if you come to see me, father has to come to the clinic, and also we will do a home visit, of course, and add on to school visit and all that. Then we add on other clinic tests to have a full assessment for the child. I think the environment is very important in the sense of how to help them manage.
I have a question for Dr. Stone, and I'm a behavior therapist, and I have a student. He is now 12 years old with autism diagnosis, but when he was 3 years old, and the mom suspected delayed speech, so she sent him to clinic, and the clinician gave him diagnosis of ADHD because what he is, he was hyperactivity. And the clinician said if he's able to sit down there for a little while, he will be able to develop, the speech skills and everything. So he missed the golden time for early intervention. So is there any way we could, prevent this kind of thing from happening? Because from my perspective view, I think it's, tragic because he missed the golden time. Now he will never be able to catch up.
I can only give you a general answer to that, and although I see and I diagnose a lot of ADHD, it's in children older than 3. And my feeling about psychiatric diagnosis at all ages is that it is not always done carefully. And the actual symptom sets are not always attended to by the clinicians. At older ages, somebody, we were talking about this yesterday, it's very easy to get a diagnosis of ADHD. It's something that clinicians are more familiar with. And as an adolescent or a young adult, you could walk into an office and say that your brother has a diagnosis of ADHD and you don't attend well, and in 30 seconds you'll walk out with a prescription for Ritalin. And I'm exaggerating a little, but that's my general response to it. It's unfortunate that that type of symptom could so easily mask other symptoms that undoubtedly were there.
Right. Great. Okay. So I think the speakers will be around for a little bit for the break, for the coffee break. So please go enjoy the coffee break. Thank you.
When we come